Okay, so 29a, the points L, M, and N lie on the same straight line. Over here, when you are looking for coordination with the phrase lie on the same straight line, you need to remember that this is actually referring to the same gradient. Okay, and when we are checking on the gradient, there are basically two formulas to use. And over here, you should be using the coordination formula where we are comparing the y and also the x. Okay, so find the value of y. In this case, you can just pair up any two sets of coordination and make it a fraction. For example, this is my set 1, this is my set 2, this is my set 3. I will first try to compare any two sets of coordination with known numbers first, right? In this case, you have coordinate m and n for both x and y with the numbers given, right? So you can just compare your gradient of mn with your L and any of the coordination here. You can compare with your LM or LN. Okay, over here I'm just going to use my coordination of L and M. So this is the first thing that you can actually write in your question. And once you already drafted this, you can just put in the gradient formula, right? So gradient of Mn, for me, I will just remember to use M minus N following the sequence that you have written. Okay, so this is my y, this is the x, this is the x, this is the y, and I'm using m minus n. So I'll begin with 9 minus 1 over 5 minus 1 equals to, same concept will apply when you're looking for Lm. So Lm, you have y minus 9 over 7 minus 5. And you can just continue to perform this until you get your y value. Right, so 9 minus 1 you get 8, 5 minus 1 you get 4, y minus 9 you will remain because this is basically involving your unknown with the numbers, and this is a 2. Okay, and from here you can just continue your simplification. You will have 2 here, y minus 9 over 2, and to continue to get your y, you will just shift your 2, multiply 2 equals to y minus 9. And to get your y, you have 4 plus 9 equals to 13. So y value over here is 13. Okay? Then for B, given a quadrilateral PQRS with vertices -1, 4, -1, -1, 5, -1, and 1, 4, calculate the area in unit square of the quadrilateral. In this case, you may not be able to see very clearly what are the coordinations location. So I would suggest you to plot by the side first. You can just put a very simple x and y axis and try to plot all these coordinates inside your Cartesian plane. Okay, so -1, 4, maybe I have a -1 here, I have 4 here. So this is my -1 and 4. Same idea will go to your -1, -1. Let's say this is my -1. I have another point here. 5, -1. So this is 5. 5, -1 is somewhere here. And you have 1, 4. So 1 is here, maybe. And 1, 4 is here. Right? So from here, you can actually see this part is actually your quadrilateral, and this is what we call a trapezium. Okay, so to get the area of your trapezium, your formula is going to be, okay, area of trapezium equals to half A plus B multiplied with your H. So A plus B, this part is referring to the pair of your parallel lines, which is here. And your H basically is your perpendicular height, right? So you can just compare A and B. The top line here, you are comparing with -1 and 1. So this is 2 units. Okay, this is from -1 to 5. So you have 6 units in total. And for your height, this is from -1 to 4. So you have 5 units. and you just multiply it together, you have 1 over 2, 8 and 5, which will bring you 20 units squared. Alright, moving on to question C. The diagram below shows PQR is an isosceles triangle such that PR equals to QR. So PR here, QR here, these has the same length. And it cuts a triangle into two similar right angle triangles, PSR and QSR. Find the length in units of RS. So you are just checking on this line. Okay, when you have two similar right angle triangle, you will exactly cut in the middle where you will have this line and this line as your perpendicular bisector. So perpendicular bisector, it means you are cutting at 90 degrees where your left and right hand side are the same. Okay, so to get your length RS, you may need, okay, let's say this is your coordination S. Okay, to find this coordinate, basically you need to find the midpoint in between your P and Q first. Okay, so you can start by checking your S, X, Y equals to the formula for midpoint. So midpoint, again, it is the average of the two sets of your coordination. So over here, I would have negative 6 plus 2 over 2, as well as 9 plus 1 over 2, which will bring you negative 4 over 2, 10 over 2, and negative 2, 5 is the answer for your coordination S. Okay, so S here is negative 2 and 5. So the second part, the question is asking you to find the length of RS, which means you are looking for this line. So to check on the distance between 2 points, we will check whether the line is referring to the horizontal line, the vertical line, or slanting line. In this case, your RS is slanting because you have different coordinates for your X and Y value. So to solve this, you will just perform your Pythagoras theorem again, right? So distance of your RS, you will just use the difference of X square plus the difference of your Y square, and you square root one more time. Okay, so RS, you have 1 minus negative 2 square plus 8 minus 5 square, and you square root. Okay, basically you are trying to find the difference in between the horizontal distance and the vertical distance between these 2 points. Okay, so over here again, you have 1 minus negative 2 is a positive 3. 3 square, you get a 9 plus. So 8 minus 5, again you get a 3. 3 square, you get another 9. So you have a surd 18. Surd 18 will bring you the value of 4.24 units.